In this video, I will go over how you'll be able to move objects in Unreal based on time and not based on frame rate. This way you can have objects that move a certain amount of meters per second or kilometers per hour. This way, objects will move the same distance no matter what your frame rate is. By the end of this video, you will understand how this can be done in Unreal and how you can implement this into your own scenes. Before we begin, I'm just going to make a simple scenario here. I'm going to create a standard cube, and by default the Unreal cube is 100 by 100 by 100 units. Now, units in Unreal are often referred to as UU or Unreal units, but they're the same as centimeters. So really, this cube is 100 by 100 by 100 centimeters. So if I want to make a stretch of road, for example, that's maybe, say, 50 meters long, what I could do is scale this cube in this axis, in X, by maybe 50 times. And that will give me 50 meters in length. So I'm just going to do that for now, and I'm going to build a little bit of a road like that, put a material on it, and I'm also going to add this car, this little temp car asset that I have. And it's nothing special. Don't make fun of the car. I just use it to move around and test out things in Unreal. But this is the best we got for this video here. I literally just made this. So we're going to put this car on the road here, and we're going to have it travel the distance of this road to show an issue that you'll run into when making games in Unreal or making scenes or cinematics in Unreal, where having a certain amount of speed or velocity for an object is important to have it time-based and not frame rate based. And most times this is a big issue that you should have solved in your games or scenes, otherwise you're going to get very unpredictable results. So if I have this car asset at the beginning of this 50-meter stretch of road, I'm going to change that car to movable so I can actually move. If it's static, Unreal won't let you add movement to it. And what we're going to do is add some simple translation or movement to this car by using a blueprint. So I'm going to open up the level blueprint, and what I'm going to do here is expand this window. I'm going to drag in my temp car asset from my outliner here, so I can bring it into the blueprint. And on my event tick, so event tick, you can see this, it says a tick is called every frame. So event tick is what happens every frame. So every frame, I'm going to add a offset to this car. So I'm going to do a local offset, and I'll turn context sensitive off, and I'll add a actor local offset. That actor or target is going to be the car, and I'm going to offset it by maybe, let's say, I guess direction it should be technically in X, and in this case it should be negative X. So I'll do -5 and compile. So when I play this, every frame it's going to add -5 in the x-axis to this car. So if we click play, oh, maybe it is +5, my bad. There we go. If we click play, the car slowly travels to the end of this 50-meter road. Now, if I want to speed that up a bit, maybe I'll do 25. So 25. And there it goes. It reaches end. So if we think about how long this takes, if I just play this and I just roughly count, I'm not going to do anything super scientific here. It's just going to be a rough estimate. So I click play and we start counting. 1, 2, 3. It's about 3 seconds it reaches the end. 1, 2, 3. Okay. So that seems okay. Maybe that's how long I want it to take before it reaches the end. The problem right now is my frame rate in Unreal is currently, if I click up here and go show frame rate or show FPS, I have about 100 frames a second. So if I change the frame rate, so down here in the command prompt, I'm going to just type t dot max FPS. So I'm going to limit the frame rate. If you watch the frame rate counter, I'm going to limit the frame rate to say, let's do 10 frames a second, which is going to be really laggy and slow. So now you can see my frame rate is 10 because I artificially lowered it to that amount. Now the reason why I'm doing this is to show a problem here. If I go back to my blueprint and it's a little bit laggy to move around. If I play this again, we assume that it would take 3 seconds for the car to travel to the end of this road. But that's not the case because this offset is happening every tick or every frame. And if your frame rate is lower, the car is not going to travel as far. So if I click play now, we'll start counting. 1, 2, 3, 4, 5. So you can see already it's taking way longer to get to the end of this road, which is a problem because now people who have a fast computer will see the characters move quicker or objects move quicker than someone with a lower frame rate. So it's not very reliable. And your frame rate changes based on many other factors. If you have more programs open on your computer, or if it's just like there's more effects in one shot or something, it's going to vary. So how can we make this frame rate independent? Something that's based on time, not based on the frame rate. So the issue that's happening right now, if you just kind of start to think about it, like what is actually going on, the problem is, since this happens every frame, if we think about it, just as like a scenario, if we're running at 10 frames a second and we have 5 seconds of gameplay go by, that's 10 frames times 5 seconds, because it's 10 frames per second, that's 50 total frames. And if the car is moving 25 units in each one of those frames, you end up with 1,250 centimeters or units traveled. Now, if you have something running much quicker, like 60 frames a second, that would be 60 frames per second times 5 seconds. That gives you 300 total frames. And if it's traveling the same amount, 25 units, in those 300 frames, you end up with 7,500 centimeters or units of total travel distance. So that's the problem that's happening right now, is our frame rate. If you have more frames, you're getting more distance. If you have less frames, you're getting less distance. So we don't want that to happen. We want it to be independent of that. We want it to be based on time. So what we can start to use is something called delta seconds that you see here. Now, what does delta seconds do? If I just disconnect this and we just run a little bit of a test, it's going to move that away. On delta seconds, I'm just going to do a print function, print string. And I'm just going to output what that number is. What is delta seconds? And the interesting thing that we'll see when we run this is at 10 frames a second, let's see the number that gets outputted, 0.1. Now let's think, if it's 10 frames a second and the delta seconds are 0.1, so 10 frames times 0.1, that equals 1. Okay, so the delta seconds essentially gets you how long it's been since the last frame has elapsed or finished. So by using delta seconds, you get like a multiplier that you can use to keep your movement to be time-based. Because right now we're doing 10 frames a second, and the delta seconds are outputting as 0.1. So in the time of 1 second, we do 10 frames. Each frame has a multiplier of 0.1. 0.1 times 10 equals 1. Now if we change our frame rate, t dot max FPS equals, let's say 60. So back to a fast frame rate. Let's see if this updates. Oh, did I not type that right? T dot max FPS equals 60. Enter. Okay, there we go. 60 frames a second. So now, 60 frames a second, if we play this exact same blueprint, and we get the delta seconds number, what is it? It's 0.016. And the cool thing about that is 0.016 is the multiplier per frame. Now let's just bring a calculator out here. If we have 60 frames and the multiplier is 0.016667 to be exact of what it said, it's pretty much 1. So it's the same thing. So we play this again. Oh, see, it changes a little bit. It'll change every time a bit. But generally, it's going to keep us fixed at producing 1 every second. So what we can end up doing is we can use those numbers or use our delta seconds, because that's constantly updated every frame, to act as a multiplier for our speed. So our solution is going to be to base our speed based on time and not based on frame. So we're still going to use this event tick. We're still going to connect our target to our car. We're still going to move a location, but what I'm going to do, instead of moving 25 units on X per frame, I'm going to right click on this, split it, so I can just access it a bit easier. And for the X amount that's going to travel, we're going to do the full distance we want the car to travel. So the full distance we want the car to travel, but in seconds, not in frame or total distance overall. How far or how fast do we want this car to travel in seconds? Well, if I want it to reach the end of this 50-meter road in, say, 5 seconds, then what I can do is I can travel 1,000 units or 10 meters every second. So what I'm going to do is take the delta seconds, multiply it by the speed I want to travel every second. So in this case, it's 1,000 units, which is 10 meters. And I want to travel 10 meters every second. So we do this, we multiply our delta seconds by how far we want it to travel every second, and that becomes our delta x location here, or our location x. And now with this, if we compile and we play and we count 1, 2, 3, 4, 5. Okay, reach the end. And now if our frame rate plummeted, let's try this as a test, t.max FPS equals 10. So terrible frame rates again, everything's slow. And we play this again. 1, 2, 3, 4, 5. Exactly the same. So it reached the end of the road in the same amount of time, 5 seconds. Even though it was laggy and stuttery, it didn't end up producing less of a distance because the movement is no longer based on frames, but on seconds. So this way, you might have to do a little bit of math, but you'll be able to get your vehicles or your objects translating based on X distance per second, per hour, whatever you want. You could do kilometers per hour, miles per hour, meters per second. You have to do a little bit of math to kind of convert that all down to seconds if it's something different like per hour. But pretty much by this way, you'll be able to get consistent and reliable movement regardless your frame rate. So hopefully it helps everyone out if you're trying to make sure that your objects move at the same speed, whether you're running at 200 frames a second or 10 frames a second. If you have any other questions about Unreal and you want to see more videos, please put some comments down below. Don't forget to subscribe and also check out my Patreon page and support me on there so I can continue making more videos. And if you do support me on the Patreon, you do get access to the PDFs, which I release on most videos, which go over all the steps that we kind of covered, except in a little bit more depth, written out, and can sometimes be useful for reviewing or just having another way of looking at this tutorial without having to rewatch the video.